Hey everyone, it's Miss Ship. We are going to learn today about inverse relations and functions. Remember what a relation is. A relation is just a set of ordered pairs. And when we talked about relations towards the beginning of the year, we looked at them and decided if they were functions or not. And if you remember, a relation is a function if it has no repeating x values. So every relation has an inverse, but that does not mean that the inverse is a function. So the relation might not be a function, the inverse might not be a function. We have to check. If a function is denoted f of x, like we normally see, f of x, g of x, h of x are common. Its inverse is this f negative 1 of x. That's not to the negative 1 power. We actually read that f inverse of x. Let's write that. So this is read f inverse of x. Okay. All right. Oops. Okay. So the graphs of a function and its inverse are a reflection over the line y equals x, or x equals y. This line comes up a lot. It's the identity line because in every single point, the y value equals the x value. We have -3, -3, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and so on and so on and so on. Okay. So if you folded this graph in half over that line, these two pieces of this function would fall on top of each other. Okay. Now this one is a little bit different because while we're reflected over the same line, this whole parabola doesn't go over here, right? We're missing this whole piece down there. But if you look at it, this piece here matches up to this piece, and this is where x is negative. So we have a restricted domain. So with a restricted domain now, you only have the top half of the parabola. Okay. All right. So if you're looking at a relation and an ordered pair is xy, then the ordered pair in its inverse is yx. You switch x and y. You switch x and y. That is the big thing to remember when you're doing inverses. So if we look at these two relations, it tells us here that they are inverses. It already tells us that. So look at the points. 1, 9, 9, 1. Okay. 3, 8, 8, 3. The x and y switch every time. Now we need to know how to find an inverse algebraically. So to find the inverse of a function, the first thing you need to do is what we just did on that last slide, and you need to switch x and y. Remember, always remember that f of x is the same thing as y. Okay, so what you're going to do is switch x and y and then solve for y to get y by itself. There's a few steps. Most of the time you'll be given something in function notation, which is going to be an f of x or a g of x. The first thing you want to do is rewrite that with y instead of the f of x. The next thing we're going to do is switch x and y. So if you see here, I switched x and y. Okay. Then we need to solve for this y right here. We need to get to that y. Well, that's a two-step equation, okay? So we're going to subtract 2 from both sides. Then I'm going to divide by 3. And I get y equals x minus 2 over 3. And I did not do a good job because I did not write it in the right form. It needs to be like this. F negative 1x equals x minus 2 over 3. Okay, so that should have been my answer. But I'm not going to go back and change it now. All right. Okay, so we're going to rewrite the function with y instead of f of x, switch x and y, and solve for y. So let's look at this one. Okay, so the first step that we need to take is to replace f of x with y. Okay. My next step, I like to draw a squiggle line before this next step. My next step is to switch x and y. Okay, you just switch them. Now I'm going to rewrite this a little bit and make some room here. I need to get rid of that fraction. I need to get rid of this fraction. 2 over 3. I want the coefficient of this y cubed to be 1. I need the number in front of the y cubed to be 1. Okay. What I'm going to do is multiply by this thing called the reciprocal. Okay. It's the fraction flipped. So when I multiply this now, I multiply straight across the top, straight across the bottom, and I would get 6 over 6. So when I go back to my problem, now this y to the third is isolated. It's by itself. And the other side says it's 3 over 2x. Okay. Now I need to get y by itself. And I have y to the third right now. I need to undo that third power. So I'm going to take the cubed root of both sides. I have the cubed root of 3 over 2x equals y. But that's not my final answer because I need inverse function notation here. F inverse of x equals the cubed root of 3 over 2 times x. Okay. So there's your inverse. Let's write a little note right here. The orange multiply by reciprocal. Write yourself a little note there that says that's what you did. Okay. I don't know what color I'm looking for. Next one. First thing I'm going to do is replace g of x with y. Draw my squiggly line. Switch my x and y. Then I need to solve for y, so I need to get y by itself. Now I have y squared, but I don't want y squared. Let me move this equal over. So I'm going to take the square root of both sides. So I have y equals the square root of x minus 4. That's not my final answer, though. F inverse of x equals x minus 4. All right. The next one. Here I need to replace f of x with y. Raymond Albert, Mama is doing something. No. He wants to play with his laser pointer. Okay. I did that. Now I'm going to switch x and y. Now that the radical is isolated, I need to get rid of the radical, so I'm going to cube both sides. I have 2y equals x minus 1 cubed. And then, let's just do it down here. Divide by 2. And then up here, we're going to write in our inverse notation x minus 1 quantity cubed divided by 2. Okay, so there's number 3. Hopefully you're getting it. Here's number 4. I'm going to change that to y. Then do this 7 times the square root of x do my squiggly line. X equals 7 square root of y. I need to get rid of the square root, but I can't do it yet because I have the 7, so I need to I need to divide both sides by 7. And then I have x over 7 equals the square root of y. I need y by itself, so I need to undo the square root. So I'm going to square both sides. Then I get y equals x over 7 squared. And I need to write my answer in function notation. So that would be f inverse of x equals x over 7 quantity squared. Okay, so there's those two. All right, last one. Same process. First thing I'm going to do is switch in a y. Now I'm going to switch x and y. Add 8 to both sides. Ooh, that's really big. I need to make that smaller. Okay. So now I'm going to rewrite this so I have a little space here. Just like we did in number 1, the very first one we did on the notes, we need to get this coefficient of y, we need to make it 1, and a positive 1. So not only do I need to multiply by 3 over 5, I need to multiply by negative 3 over 5. Okay. Make sure on this side over here that you use parentheses. Okay. So now we're going to have y equals negative 3 over 5 times x plus 8. Okay, that might be the answer. But you might be looking at multiple choice answers, and none of them look just like that. So remember, we can now distribute that fraction and when we multiply fractions, we just multiply straight across the top and straight across the bottom. So this isn't the tricky one. No common denominators needed. And this becomes minus 24 over 5. Then I need to write in function notation, negative 3 over 5x minus 24 over 5. Obviously, That 24 over 5, we cannot simplify that. If we could, we would. So you should always, always, always simplify fractions if you can. Okay, so here's a good look at that one. Okay, feel free to watch this video as many times as you'd like. The filled out slides are also on Canvas for you to access. Your homework is a quizzes. Let me know if you have any questions. Okay.